Good day all of you. In this class, I want to explain about method of analysis of practical feedback circuits. Yes. In this concept, we are going to analyze practical feedback circuits. Okay. What is that method of analysis? I'll briefly explain first and then I'll explain it in detail. Okay. So, while doing the analysis of any practical feedback circuit, you must know the type of feedback. You have to identify the type of feedback. We have four types: voltage series, current series, voltage shunt and current shunt. We have to identify the type of feedback. And then, we have to find A. What is A? Gain. Gain without feedback. To find the gain without feedback, first you must remove the feedback present in the given circuit. Okay? So, to find this A, you have to remove the feedback. And then, find feedback factor beta. And then find Ri and R0. Okay, you have to find Ri and R0 of the given circuit after removing the feedback, because you have to find A. Then, as you know A and beta, you can find D. D is equal to 1 plus A beta. Okay. And then, you can find AF, RIF and RF. You know AF is A by 1 plus A beta. RIF is sometimes Ri into D or Ri by D. R0F is sometimes R0 into D and R0 by D. Okay. So, this is the procedure to find any or to analyze any practical feedback circuits. Okay. So, now I'll explain it in detail. Okay. So, what is that? What is the first part? The first part is you have to identify the type of feedback network. Okay. So, the first one. What is the first step? You have to identify the type of feedback. Okay. To identify the feedback, first you must know what is the type of sampling and what is the type of mixing. Because sampling and mixing, these two decides the type of feedback. Okay. So, to identify the feedback, you must know the type of sampling and the type of mixing. Okay. So, first to identify the sampling, first we'll see how to identify the sampling. Okay. Yes, first, if output V0 is 0, the output voltage V0 is 0. If V0 is 0, making the feedback signal is equal to 0. Okay. Then the sampling is said to be voltage sampling. Sampling is said to be voltage sampling. Okay. And the next point, if I0 is equal to 0, if the output loop is open, if it implies XF is 0. So, when I0 is equal to 0, if XF is 0, then means XF means feedback, then it is said to be current sampling. Okay. Yes. If output current is 0, then the feedback is 0. Means automatically the sampling is current sampling. The output is, we are taking the output in the form of current. Same way, if output voltage is 0, feedback is 0, then automatically it is voltage sampling, because if output is 0, feedback is 0. So, obviously the output is in the form of voltage. Okay. So, after identifying the sampling, you have to identify the type of mixing. Okay. How to identify the type of mixing? We have two types of mixing networks. Okay. Series mixing and shunt mixing. Yes. How to identify it? If your feedback signal is subtracted from the externally applied signal. What is the externally applied signal? Either Vs or Is. Okay. So if your feedback signal is subtracted from the external signal as a voltage in that input loop, then it is said to be series mixing. Okay. Yes, if the feedback signal is subtracted from the externally applied signal as a voltage, okay, you have to subtract the feedback from the externally applied voltage, means your feedback signal must be voltage. Okay, you can mix voltages only when there is series mixing. Okay, so if XF is subtracted from the externally applied signal as a voltage, then it is said to be, yes, what type of mixing it is? It is said to be series mixing. Because when the circuit is in series only, yes, you can apply KVL so that you can add all the voltages. Okay. Then the second one, if XF is subtracted as a current from the externally applied signal in the input loop, then that is said to be shunt mixing. Okay, means if XF is subtracted from the externally applied signal as a current, okay, means the externally applied signal must be current, then only you can subtract another current from that externally applied current. Okay, so you must subtract this as current. Okay, so you can mix or add or subtract the currents only if your circuit is like the circuit you can apply where you can apply the KCL. Okay, you can apply KCL when there are nodes and branches. Okay, so that type of mixing is called shunt mixing. Okay, so after identifying the sampling and mixing, you can find the type of feedback. Okay, yes, so see here, voltage sampling, current sampling, series mixing and shunt mixing. So two types of samplings and two types of mixings are over. Yes, you can find so now you can find the type of feedback network. Okay, then what about the next step? Yes, what do you have to do? You have to find, the next step is you have to find A. To find A is the gain without feedback. To find A, you have to separate the feedback, means you have to separate input and you have to separate output. There should not be any connection from output to input in the form of feedback. Okay, so for that, the next step is you have to find input circuit. To find input circuit. Okay, yes, to find input circuit, what are the steps? Yes. When you are finding input circuit, you have to find with respect to the output. Yes, when it is voltage sampling, make V0 is equal to 0. Yes, means after identifying the sampling, to find the input circuit, you have to make V0 is equal to 0 and then you have to see what is the circuit. Then if it is current sampling, you have to make I0 is equal to 0. You have to make I0 is equal to 0. Okay. So then you can find the input circuit. Okay. After identifying the sampling, if it is voltage, make output short and then you can find the input circuit. Or if it is current sampling, make output open, you can find the input circuit. Okay. Then the next step to find output circuit. Yes. To find the output circuit, yes, you must find the output circuit with respect to the mixing. Okay. So, yes, what is the point here? The point is, yes, for series mixing, if the mixing identified is series mixing, make II is equal to 0 by opening the input loop and then you have to find the output circuit. Or for shunt mixing, make input voltage is equal to 0. Yes. So after identifying the mixing, yes, either you have to make II is equal to 0 or for the second case you have to make Vi is equal to 0 to find the output circuit. Okay. So yes, if you observe these two steps, yes, here we got the input circuit And here we got the output circuit separately. If the input circuit and its output circuits are separated, what does it mean? It means that we eliminated the feedback, or we eliminated a connection between the output and input in the form of feedback. Okay. So steps 2 and 3 ensures that there is no feedback. So after getting this input and output circuit, you have to mix these two input and output circuit. You have to draw it is in the form of a single circuit. Then find your A. Okay. To find that A, what do you have to do? After finding the input output circuit, then you have to replace the transistor with the H parameter model. You have to draw the H parameter model equivalent circuit for your input and output circuit. Okay. Then find A and then beta and then Ri and R naught. You have to find all these things from that equivalent circuit. Okay. Then you can find, yes, AF, RIF and R naught F. Okay. So this is totally the method of analysis of practical feedback circuits. Okay. So I'll repeat first. Yes. So for doing the analysis of any practical feedback circuit, first you have to identify the type of feedback. Okay. To identify the type of feedback, what do you have to know? You have to know about sampling and mixing networks. Okay. How to identify the sampling? Make V0 is equal to 0. If V0 is equal to 0, make the feedback is equal to 0. Then the output is said to be a voltage sampled output. And the second is, if I0 is equal to 0, your feedback is 0, then the sampling is said to be current sampling. And then, how to identify the mixing? Yes, if the feedback signal is subtracted from the externally applied signal as a voltage, then it is said to be series mixing. Okay, if the feedback signal is subtracted from the externally applied signal as a current, then it is shunt mixing. Then after finding this feedback, you have to find A, gain without feedback. To find the gain without feedback, what you have to do? You must eliminate the feedback. Means you must eliminate a connection between output and input, which ensures feedback. Okay. So to find that input circuit, you have to follow the output conditions. When the output is voltage sample, make V0 is equal to 0 to find the input circuit. When it is current sampling, make I0 is equal to 0 to find the input circuit. And next you have to find the output circuit. Output circuit is found with respect to the mixing concept. Okay. So for series mixing, make II is equal to 0, means by opening the input loop. And for shunt mixing, make Vi is equal to 0 by shorting the input loop. Okay. Then you can find the output circuit. After finding the input circuit and output circuit separately, at this end, you have to draw the input and output circuit in the form of a single circuit. Okay. Then you have to draw the H parameter model equivalent circuit of the previous circuit. Then you have to find from that H parameter model equivalent circuit, you have to find A, beta, Ri, R naught. Okay. Then find your AF, RIF, R naught F. Okay. Yes, meanwhile to find AF, RIF, R naught F, you have to find here the D sensitivity D, which is 1 plus A beta. Okay. So this is the procedure of analyzing a practical feedback circuits. Okay. So based on this, in the next class, we are going to analyze the 4 types of feedback amplifier circuits. Okay. Thank you. Thank you for watching this video. If you like this video, please don't forget to like, share and subscribe.